Hello, Internet! Whenever you have to do with text, you have to pre-process your text to make it machine ready, especially if you want to have an artificial intelligence solution applied to your text. So we're here in Keras, and we're here with working with pre-processing layers, and then we have here text pre-processing. And I want to give you today a feeling about text preprocessing and what Keras can do and how easy it can be if you have something like Keras here. They have a beautiful thing called TensorFlow Keras Layers Text Vectorization. And what it does, it turns raw strings, so your sentences, your documents, into an encoded representation that can be read by an embedding layer or a dense layer. And please notice that we are looking here at embedding or dense. This means integer or float. And if you do not know what I mean, short reminder, text vectorization. So we are working with text. We will use the Keras text vectorization layer. Remember, it's a layer. We are operating in TensorFlow. And it will transform a batch of strings into either. And again, a list of token indices. And this is a one-dimensional tensor. And now the important part of integer token indices. Or if you're going for a dense layer, a dense representation. And you know, important, when the tensor of float values representing data but a token. So very easy. What it does, standardize your example. You have your lowercasing, your punctuation stripping, split into words, recombine the words into n-grams if you want, index your tokens. So associate a unique value with each token, and then transform each example, each sentence using this index, either into a vector of integers or a dense float vector. Again, we have this duality. Integer vectors or dense float vectors. And now, before we dive into anything, we go here in Keras to the Layers API and we have a look at this. No, let's do something else. Do I find this? Yes, this is here in our notebook. Let's jump in our notebook. I have here a Keras Preprocessing layer text notebook. I'll leave you the link in the description. This is officially by Keras for you to learn, to experience this. And what we have here is sentences. 1, 2, 3, 4, 5, some sentences. And then you say, okay, I define now a layer. And this layer is simple text vectorization. So we use here the command that is given in TensorFlow with Keras, layers text vectorization. And here we go. And then we say, okay, we take this layer, we apply an adapt command, and I will show you in a second what this means, to the data, to our sentences. And then we have a vectorized text, the layer on our data. And show me the text, show me the vectorized text. And here you have it. And this is what I want you to see. You have your sentences, your data, in whatever language you want. It doesn't matter, because for machine learning, we have to transform it in a tensor algebra. And here is the exact machine-readable thing that we will use, that you need for if you build a model for a dense layer, for an embedding layer, whatsoever. So this is it. This is exactly what we are looking for. This is why the command layers text vectorization exists. We want to have this beautiful representation. And as you can see, for each word in a sentence, I would not even know where the words begin or end, we have found a representation that is just great. So, and now that we have this command, layers.text vectorization, and as you can see, we use it here purely default, but I want you to understand there are a lot of parameters and they are beautiful. What you have, the maximum number of tokens. If this is your vocabulary, do you want to have 4,000 vocabulary? Do you want to have 50,000 vocabulary, which I recommend a vocabulary at about 50,000. You can have a really good understanding. To standardize, lower and strip punctuation, so lowercase and the punctuation is gone if you activate this. where do you want to split? White space or any other character, you can define it here. Do you want to have your words then associated to n-grams, combined to an n-gram, to a bigram or trigram, whatsoever? Now, very important is here the output mode. Integer, as I showed you for embeddings. Now, the output sequence length, you can even define this. You can pad it to a maximum token length. You can even define your vocabulary. Imagine you have, with some other AI or whatever, you have a defined list of vocabulary items. So all the words you want to have in your vocabulary and nothing else. Then you have the option to fit it into your vocabulary, and we do not have to start the adapt command, because then we have a vocabulary given. You can go with the IDF whites, you have sparse, ragged, whatsoever. So beautiful. Make yourself familiar with all of this. I'll leave you the link to this also in the description. Maximum tokens, standard data size, split n-grams, output mode. Now, the output mode, this is important. We already found output mode is integer, but you can also have multi-hot, or you can have TF-IDF or whatsoever. So be careful with, especially with the output mode, because it gives you the specification for the output of the layer. Yes, sequence length, vocabulary, I told you, the weight, sparse. No. A vectorization layer that lowercase text splits on white space. Yeah, let's have a look at a demonstration. So let's make it even a little bit bigger. Can I increase the size? No, not now, not here. Yes. Hold on. Okay, here we go. So we have a data set. Great. We have a list of 3 words. We defined a maximum vocabulary size of 5,000 words. Okay. And a maximum sequence length of 4. Well, we don't need this. And then we create the layer. So here we go. At first, we have our Keras layers text vectorization. And now we start with 3 parameters. The maximum tokens are the maximum features, 5,000. The maximum length of our vocabulary, if you want. Now the output mode is integer. Careful, integer. And the output sequence length is 4. So now that a vocabulary has been created, we have to call adapt. And we call adapt on text-only dataset to create the vocabulary. As I showed you, if you do not provide each word of your vocabulary that you want to have, you just call adapt and the vocabulary is created for you automatically. You don't have to batch, but for large dataset, yeah, you know. No? So you say vectorized layer.adapt and then your dataset. And then we start with just a very simple model. We use the easiest model, a sequential model. And then we create an explicit input layer. Now the input layer is clear, has to have the shape of 1. That there's exactly 1 string per input, per batch. And the D type needs to be string because we want to have sentences. Or whatever you want to have. You can go for paragraphs or whatever. So what do you say? Model, add, and then we have here Keras input layer. String and shape 1. Now the first layer in our model is now the vectorization layer. And after this layer we have a tensor of shape containing our vocabulary indices. And the shape is batch size and maximum length. So what we do, we say model, add, and just vectorization layer. And remember, the vectorized layer is exactly our text vectorization with our 3 parameters. So we add this, we have an input, we have here our text vectorization. And if you have now an input data and you say model.predict on this input data, you will get a result. So beautiful. Another very short demonstration if you have your vocabulary. So this means you want to have your vocabulary 4 words, earth, wind, and fire. This is it. And then you create the layer passing the vocabulary directly. And here we go. We say vocabulary equals vocabulary data. That is a list of words that we defined here. This is it. That's all. And you pass the vocabulary. You don't need to adapt the layer. The vocabulary is already set. We have a padding token and a UNK token. Yes, beautiful. So you can even get your interpretation, your representation, vectorized layer, dot get vocabulary. So you see, this is easy. This is the command we're going to focus. This is what I want you to understand, how beautiful this thing is. And some other pre-processing data before the model or inside the model. Yes, in my last video, I showed you that there are two ways of using pre-processing layers. Now, either you can use it for the training phase or for the inference. Now, let's have a look at that. If you want to make the model or the layer part of the model, it is very easy. You have your input layer, you have your pre-processing layer, and then you have your output. And then you just say Keras model input, outputs, and done. This is it. And with this option, the pre-processing will happen on device synchronously with the rest of the model, meaning it will benefit from GPU acceleration. Now, the second option that I already told you is applied only to your data. So if we have a TensorFlow input data pipeline, TF data, remember there's an own video I did on TF data, dataset. So as to obtain a dataset that yields batches of preprocessed data like this. So this is a very simple command. We have a map command with 2-parameter lambda, where we have now our preprocessing layer integrated. In this option, your preprocessing will happen on CPU, asynchronously. In addition, you can call the prefetch and the autotune. I also showed you in the last video on the dataset. The preprocessing will happen more efficiently between the CPU and GPU coordination in parallel with the training. So you say dataset, prefetch, TF data, autotune. And they said this is the best option for text vectorization and all structured data preprocessing layers. Beautiful. You can have the TPU also. Beautiful, beautiful, beautiful. Benefits of doing pre-processing inside a model before we go to the code. Yes, we know this, multi-worker quick training, yes. So here we have this. What this is too complicated. This we have done. Yeah, example, why not? So here we go, a quick recipe. Let's go to a recipe. Feature encoding, no. Categorical, no. What I want to show you here. Encoding text as a sequence of token indices. Now we are here in the integer representation, and this is how you should pre-process your text to be passed to an embedding layer. So here we go. We have our data. We have 1, 2, 3, 4 sentences, a list of 4 sentences. And then, very easy, we define our text vectorization command with the parameter that we want to have our output mode in integer. Great. Now, since we do not fed the vocabulary into it, we have that the text vectorizer adapt the adapt command to our data. So we create now the vocabulary and index the vocabulary. Then you can try out the layout. You have a text vectorization of something. You create a NumPy. And then you build your model. Again, you have your input model. Very easy. Then you have an embedding model, as I showed you. Then you have some other layers. You have some dense layers. And you have your model with input and output standard. Now, create a labeled dataset with unknown tokens. This is it. And if you remember, was there blue? No, there was no blue. White is skies out. No. So here, blue to blue is now a new wording. Pre-processing the strings, turning them into sequences. And this is exactly how I showed you the map of a lambda with a text vectorizer. Then you compile the model with some loss function, whatever you like. This is just for demonstration. We just go for the default. And you have your model.fit training dataset. Now, here comes the important part. This is the training model. So as you can see here, we use here our training data, and we apply the text vectorization on the training data, so that whenever we run the model, the training model, train the model, we have our data already prepared for us in the correct representation. Now, for inference, whenever you want to apply this model to a particular task, let's say I give you a new document, a new 1 million sentences, your input will now be sentences, so strings. So what we do now for inference, we have now a slightly different model. We call it an end-to-end model because this is our operational model. Of course, Keras input-outputs. Now the inputs are, as I showed you, sentences from type strings. This is our sentences. We have our text vectorization, and we define a model, whatever it is. So as you can see now, our input now is the documentation. We have now a layer of text vectorization. So we have now exactly what we wanted in the very first place for these pre-processing layers in Keras, that it is now part of the model. So whatever you have now in the model development, in the model evolution, you have your text pre-processing as an integral part in your layer. And then you can call the end-to-end model on some test data. Let's do this. Let's run through this. So the encoded text is very easy. The encoded text is here from the brain is deeper than the sea. This is now our integer representation. Then our training model, just one step. And then we have a model output. This is our tensor that comes out. This is an integer representation. So now if you want to have this, for example, to be passed to a dense layer, so if you want to have a float representation, encoding text, now the second example, as a dense matrix of n-grams. And now we have multi-hot encoding. So we are now playing around a little bit with the option we have with our text vectorization. So we have some sentences, 4 sentences, and then we say, okay, now our text vectorization, now we have 2 new parameters defined. Instead of integer, we go with multi-hot. On n-grams, we say we want to have bigrams. So multi-hot output mode, if you want to know, multi-hot, argument split output mode. Here we go, integer, here we go, output mode is integer, this token turn, multi-hot. Outputs a single integer array per batch of either vocab size or max token size, containing ones in all elements where the token mapped to the index exists at least once in the batch item. Okay. Where are we? Now, stop here. And then we have to construct our vocabulary. So we did this on this, we run through this, and we get an output. Beautiful. I was already here. My goodness, here. This is where I left off. No, hot. Where was my hot model? Come on, multi-hot. Here we go. So then we have input, the text vectorization, dense layer now, for example, very simple model. This is it, input, output. And we have now a labeled data set. These are our 2 sentences. Then we do now for the training, the pre-processing of our text vectorization layer only on the data. Now it's not part of the model. Then we just compile, define the loss function, and do the training. And for inference, as I showed you, it's exactly the same. We have now a d-type string, and we have a specific layer for text vectorization of our input, and this is it. Now, if you run this too, you see we have now here our representation of the encoded text. There. This is now it. And 5 calls, yeah, forget it. And we have an output, and now this is this output here. Now you can go for a dense matrix of n-grams with TF-IDF weighting. But yeah, you just understand what I want to show you. I'll leave you a link to this official Keras notebook in the description here. No problem. Those are the authors, and was last modified 2021. Okay, so you might say, this is nice, fine. Can we have a complete example? Yes. And also here from Keras, we have a text classification from scratch. Those are the authors of the notebook. It was created in 2020. So what we do, let's run through this, the movie database, the review sentiment classification. We have to load the data. Yes, of course, we create it. ATMB. Yes, come on. Faster, faster, faster. Here, consumption represent 100 room. Yes. Just load the data, no problem at all. So, the batch size. And then what we do is we have to, for each model, the training data set. Then we have the validation data set, and we have the test data set. So we have our 3 standard data sets. And as you can see, KERAS Preprocessing text dataset from directory. We have a directory of files, and we can easily import all the file with this command text dataset from directory. Batch size, validation, splitting, yes, yes, yes. Can we already see? 25,000 files, 5,000 for validation, number of batches, yes, beautiful. So let's have a look at this. It's important to take a look at your raw data to ensure the normalization, tokenization. Yes, always check with your own eyes. I've seen tons of science fiction from the 70s, well, blah, blah, blah. Yeah, and we have 1, and then we have a sentence, blah, 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 and then we have a sentiment value 0. So data looks good. Prepare the data. Import our text vectorization. We have HTML break tags. We want to remove those tags. Yes, so we define some custom standardization. A regex replace. Okay, this is easy. We choose our vocabulary size to have a vocabulary of 20,000 words. The embedding dimension, if you want a hidden dimension, is 128, and the sequence length is 500. So to normalize, split and map strings to integer, set our output mode to integer, yes. Default split function, yes. So here's our Keras layer text vectorization command with our parameters custom. We have defined this, the maximum features defined integer. For I'm embedding, this is what we're looking for. Call adapt for text-only dataset to create a vocabulary. Yes, exactly. Here we call adapt. We want to have our vocabulary created for us automatically. Great. Come on. Okay. So we go on. 2 options to vectorize the data. Again, this is just a repeat. Make it part of the model. You know this. You have your input model. You have your string configuration. Then you have your vectorized layer. And then you have embedding, because this is now an example to have an embedding layer in our model. So this is it, the way you go, or you apply it only to the text data set. Especially if you do the training, this is faster. Of course, this one here, if you do the inference, this is the recommended path in option 2. So option 2, asynchronous CPU processing of data, yes, yes, yes. Vectorized tense, yes, we expanded for 1 dimension. We have to map vectorized text, buffering, yes, prefetch. Prefetch is the typical buffer size defined. You can also say prefetch to auto-tune, but whatever, here we go. We choose a simple COFNet starting with an embedding layer. So this is our input. We have integer 64. Add a layer to map those vocab indices into a space of the dimensionality of our embedding layer. Remember, it's 128. So our embedding dimension is 128. We have some layers, some vanilla layers, some dense layers. Yes, yes, yes. We have the model with inputs and prediction, and we have the compilation with binary cross entropy, our Atom optimizer. Everything we know, we run. Yeah, let's do this. That you can see thing, and then we have 3 epochs. This is gonna take maybe a little bit of time. Oh, train is not defined. Oh yeah, I have to do everything, yeah. So we define this, this, and this. So here we go with our epoch. Oh, 2 minutes, heaven's sake. Yeah, okay, it's quite some data set. And then you evaluate the model. This is the command, you know, model.evaluate on your test data set. And if you want to make an end-to-end model, no problem at all. To obtain a model capable of processing raw strings, this means your sentences, your document, paragraphs, or whatever you have for text processing, text pre-processing with Keras preprocessing layers, you can simply create a new model. Whatever we already discussed, you have now the string, your sentence input, because you have the raw data. These are your pure sentences. Then you turn strings into the vocab indices with our vectorization layers. And then you turn the vocabulation indices into predictions. Beautiful with your model. And your end-to-end model is input, output. You compile it, you have gross entropy. Again, atom. And this is it. So you can test it. Yes. Okay. Epoch. Yes, epoch 1 takes another 40 seconds. Yeah, I guess we don't have to wait for the execution. I think it is clear. The nice thing, end-to-end model, your input is the pure sentences, and the output is exactly whatever you build the model for. So, yips. Anything else? Classification, there is, of course. I'll leave you the link here. Where they explain this to you in a little bit more detail. Have a look at this. This was here, sentiment analysis we did. This is too complicated, yeah. The CPU and GPU, if you want to optimize it, with number of parallel calls, with TF data auto-tune and the prefetch command. This I will do maybe in another video. But it's very nice, maybe for some experts. So this was the command here, and this is working with pre-processing layers. This is where we started with Keras. I think this is it. Jesus, almost half an hour. So I say, I hope you enjoyed it a little bit. Just get a feeling what you can do with Keras, especially with the pre-processing layers. This is really great. And whenever you are working with text, take advantage of Keras pre-processing layers. It makes life so much easier. All the work is done for you. It is already pre-programmed for you. So enjoy it, apply it, like, subscribe, and I see you in the next video.